Hello, here's another AQA A-level multi-choice question on the particles topic. If you want to try and do this question yourself, pause the video now. If you've got the answer A, well done. Okay, which diagram represents electron capture? Electron capture is one of these interactions or reactions that you just need to know. And it consists of a proton in the nucleus capturing an electron from the inner orbital, and that goes on to produce a neutron and an electron neutrino. And you really just need to know that. So these diagrams, these Feynman diagrams, one of these represents what's going on here. Just a quick reminder, when you read a Feynman diagram, you should read them with time moving in this direction. So at the bottom we've got the things, if you like, the reactants, the things we start with, reactants if it was a chemical reaction, and at the top we've got the things that are produced from that interaction. And between them, these W plus in this particular case, or W minus, these represent the exchange particles, the particles that cause the interaction to take place. In this particular case, it's a weak interaction, so there's a W boson, maybe a W plus, maybe a W minus boson. We'll look at why it's a W plus in a second. So first of all, which one shows the correct products? The correct reactants and the correct products. So proton and electron to start with, producing a neutron and a neutrino. Yeah, could be A, that's a possibility. Yeah, could be B. Could it be C? No, because there we've got an anti-electron neutrino, and that wouldn't work. Same with D. The reason that wouldn't work is if we looked at lepton number, the proton has a lepton number of 0, an electron has a lepton number, or an electron lepton number of +1. So on this side of the equation we've got lepton number of +1. In that case we're going to need lepton number of +1 on the other side. Neutron isn't a lepton, so lepton number 0. An electron neutrino has a lepton number of +1. An anti-electron neutrino would have a lepton number of -1. So the lepton number would not have been conserved if it had been an anti-electron neutrino. Okay, so which one is it, A or B? And the only difference between the two is whether the interaction is with a W plus boson or a W minus boson. Well, the plus or the minus represents the charge which is being carried across in this particular case. And we can see we're starting off with a positive charge, and from the proton, and the neutron on this side is ending up with no charge, so the positive charge is being carried away. So yeah, A is correct. It wouldn't work with the negative charge being carried away because the proton doesn't have a positive charge, so that one is not correct. Okay, I hope you found this video useful. I hope my explanation was useful and helpful. If it was, click on that subscribe button please, share with your friends, and watch more in the series. Thank you for watching.